Hi everyone, just wanted to make a video kind of describing or helping the understanding of how to use mollier diagrams. I know when I first learned about them from Lobenberg, I was very confused. I actually had to corner him after class and get him to explain it to me at least 3 times as to how this thing works. And I understand that some of you might be in the same boat as me and might be confused as to how to use this chart and how to derive the information that you need. Now, with that being said, I have a very basic knowledge of this, so I might get things wrong. And if I do get things wrong, please do let me know. Send me a message, write a comment, publicly humiliate me. That usually gets the point across. Alrighty, so first let's talk about the axes. So we have temperature, that's the y-axis, it increases in that direction, up. And we have the water content in grams per kilogram in air, which increases towards the right and acts as your x-axis. I'm going to refer to water content as WC, just to save, a nanosecond. If we zoom in on the whole chart, we see these decimal values. We see 0.2, 0.3, 0.4. These are referred to as your relative humidity, which I'm denoting as RH. Now, relative humidity is the actual amount of water that's in the air compared to the maximum amount of water that air can hold. So let's say a sample of air holds 6 grams of water. But theoretically, at the temperature it's at, it should be able to hold, let's say, 12 grams. Therefore, the relative humidity is 50%. And that's where that value comes from. All right, now that we've kind of talked about the different values that we're using, the different axes and units that we're going to be working with, let's talk about that contraption that was mentioned in class. I don't know what it's called, but I drew it to the best of my ability from memory. It's a bit simple, but it's easier to understand that way. Okay, so we have particles that are basically moved up into the chamber, and they're mixed with air so that they're free-floating particles. It makes it very fluid and smooth, like the sand that he mentioned. So let's say at this point right here, the particle/air mixture is at 20 degrees Celsius. And the relative humidity of that is that particle and air mixture is 50%. Okay, so now we know 20 degrees Celsius and 50%. So we go back to the diagram and we find 50%, we find 20 degrees Celsius, and we go down the nice curve until we hit the 20 degrees Celsius right there. Now, in order to figure out the water content, we look directly up. Here I'm drawing a dotted line, and we see it falls between 7 and 8. So I'm going to just refer to that as 7.5. So, going back to here, this tells us that the water content of this mixture is 7.5 grams per kilogram. Okay, so the particles are moving up. They're moving up into the chamber. And at this point, these particles are heated. They are heated to, let's say, and I'm choosing a value here, let's say 40 degrees Celsius. Okay? At this point, we haven't added any moisture. So no new water has come in, meaning the water content of this mixture is still, sorry, that was from the example, is still 7.5 grams. But since we've added heat, we've increased the capacity of moisture that the air can hold. So here we have currently 7.5 grams. But now let's say the air can hold 100 grams of water. And as a result, the relative humidity changes. And it changes now to 7.5%. Okay, so now we have new values. We have 40 degrees Celsius. We have the 7.5 grams. Now, since the water amount in grams didn't change, we don't need to shift from or towards the right. Sorry, we don't need to shift this way because there was no change in water amount. But the only shift we do make is up. And we shift all the way up to 40. Because that's what we changed the temperature to. Okay, so the mixture is 40 degrees Celsius at a water concentration or water content of 7.5 grams. Now, a third measurement is taken. A third measurement is taken when the particles are being collected. And at this point, we notice that the fluid or the mixture is at 30 degrees Celsius. And the relative humidity, I don't know how they measure it, but the relative humidity is 70%. Okay, so we have a new value to work with. We notice that the temperature dropped from 40 degrees Celsius to 30 degrees Celsius. That means energy was lost somewhere. In this diagram and the relationship between energy, the higher the temperature, the more energy the system has. So, a decrease in temperature means a decrease in energy. Well, where did that energy go? Well, in this chamber, we kind of squirt it with water so that we can form the granules that we see in our tablets that contain the medicinal ingredient. So it is because of water that we can kind of clump them here. These are my water molecules. And make these nice, even circular shapes that go in our tablets. As the water is sprayed, they clump up. So where does this energy loss occur? Well, the water that we've shot into the apparatus, some of it evaporates. And this little wavy line, wavy arrow, is my way of showing evaporation. Evaporates because of the temperature. And that evaporation takes energy out of the system. So, now going back to the mollier, whatever you want to say, diagram, we know that the humidity, the relative humidity has increased. So I'm going to use a different color now. Let's use orange. Is at 70%. And the temperature is at 30 degrees. So we go up to right here. 30. Now, we notice that we started here, but now we've ended up here. So, the transition that occurred was this arrow right here. And now, we can figure out the water content, the water that was absorbed by the system to make the granules. So we go up and we see it's 19 grams per kilogram. Okay, so now that we're back here, we know that the new water content of this mixture is 19 grams per kilogram. So, how much water was absorbed by the powder particles, to make these granules? Well, we do some quick maths. We go 19 minus 7.5, and since I'm paranoid, I'm just gonna double check my math in my calculator so I don't seem like a complete idiot in front of all of you. And that is, yes, okay. So that comes out to 11.5 grams per kilogram change of water content. So the system gained this much water content in order to produce these bad boys right here. And that's basically how we use the mollier diagrams in order to figure out water content, figure out relative humidity and the percentage value of that humidity. I hope that this was helpful. If it was confusing, please do let me know. I can try to explain it a bit better. If I got anything wrong, let me know about that as well. If you have any additional questions, I think it's best not to ask me because I don't know much. But, maybe Lobenberg can help you out with that.